With over 500 million users and counting, Excel is a long-time favorite for presenting data. Database workers live in SQL, the number one database environment. And SAS? SAS is the leader in analytics. SAS Viya is a cloud-enabled in-memory analytics engine that provides quick, accurate, and reliable analytic insights. Hi, I'm Charu, a technical trainer at SAS. Want to stay in the comfort of SAS while beckoning Excel in to join data using ProcSQL? Then you must watch my presentation to see this incredible trio in action. I'll show you how to bring in data from Excel to SAS Viya using SAS engines. We'll learn to join multiple Excel spreadsheets within SAS Viya using ProcSQL. And then we'll do some data crunching, we'll summarize some data, and then finally send the results back to Excel, all in the comfort of SAS. When I launch SAS Studio from within SAS Viya, the first thing I see is the screen. There are quite a few items that we want to explore here, and the very first thing I will do is go F11, go to full screen mode. Then I want to start examining what all is available on my screen. On the left side, we have a few widgets, and we'll be exploring primarily the second from the top and the second from the bottom. The first one is, of course, start page, open files. You'll see files that you have already opened there. The second icon stands for the Explorer. Here is where you can create a new folder where you can upload data. And I already have created one here, but you could certainly create a new folder shortcut by going to this new icon, building a folder shortcut, giving it a name and a location. So that's something I already have done. I've created a shortcut to my code as well as my SAS Excel workbooks that I'll be reading into SAS. Now, if you haven't already got the data and the code in here, easiest way is to use the Upload Files button. Then you are prompted with this window with the plus button to add. And then I'll go to my D drive and the workshop folder where I know that I have a whole bunch of SAS programs and Excel workbooks. I'll open one up from there. I'm actually going to skip this step, but certainly if you want to, you can either choose a single file or with the control key depressed, you could choose multiple files that you wish to upload. Given that we've already done that, I'll cancel this step. And then the next is a steps icon, and then you have tasks, snippets, or we'll head over to the libraries icon. This is something you would be familiar with as a SAS programmer. It's got the standard SAS libraries, and we'll be building our own. That's as far as the left side of my screen goes. In the center of the screen are options for those who might need some hand-holding if you're just starting out with SAS Studio. I'll close that up. I'll be doing the hand-holding for you, so we don't need that. Now, I want to bring in programs, and so I'll go to my Explorer window, and I'll pop open the very first program. Let's make that a bit bigger. This one here, Read Data from Excel. When you look at this screen, if you feel that the font size is not big enough, you can certainly make a change by going to the Options menu, going to Preferences, and there, if I go to Editors on the left, on the right side, I'll click Editor Options, and then I can change the colors and font. I have this font picked from this selection, and I've chosen a font size of 24. Let's cancel there. I think this is large enough. I've tested it before from a teaching perspective, and I know it shows up nicely. Next, I want to look at the Excel workbooks that I'll be bringing into SAS to do some analytics. Customers.xlsx. I would like to take a look at that first So I go to that location where I've already uploaded this Excel workbook, and I'll right click and download the file. This is how I'll be able to launch that Excel workbook, and I can see that I have about 5,000 rows of data, and each row has got customer demographics. So unique customer information like their IDs, their names, and a lot more like street names, city, etc. That's my first workbook. I'll close it up and open up the orders.xlsx. Same idea, I download the file and then I'll open it up to launch Excel. Something I'll notice is each of these workbooks has sheets. This workbook has only one sheet called orders. The customers workbook had only one sheet called customers. Here we have information about each order that a customer placed, and then we've got more information about where they are from and information about the product ID and so on and so forth, quantity. These are all columns we'll use for doing some summarization of our data at a later stage. I'll close it up and let's begin to do the work of starting to bring in Excel to do the analysis. To do that, I'm going to use the live name statement. The live name statement is the exact same statement you as a SAS programmer is familiar with. It needs three key pieces of information. It needs a library reference, it needs an engine, and it needs a location of your data to point to. So this live name statement really harks back to the best strength of SAS. And I'm talking about the power of SAS to read virtually any data, whether it is SAS datasets, whether it's Excel worksheets, whether it's Hadoop, Oracle, you name it. And how does SAS do this? It does it by these powerful engines. Engines allow me to point to a location, and the engines do the heavy lifting of showing the data as if it's a SAS dataset. And that's key. They're going to show it as if it's a SAS dataset in a SAS data library. So in terms of technicalities, a live name statement is pretty straightforward. Give me the library reference. CST is what I've called it. Give me the engine. I'll use the XLSX engine. And then give me the location. Now here is something unusual. Mostly when we assign a library to a SAS, to a bunch of SAS datasets, I'll stop with the folder location. When it comes to Excel, we have to remember that an entire Excel workbook is going to be treated like a SAS data library. Sheets in the Excel workbook will be treated as SAS datasets. And that's why we need to provide the entire Excel workbook name and the path. You'll notice I've used a macro here. The %let path allows me to create a macro variable called path and assign a value. Why do I use this? Because I don't want to keep on retyping the path. Call it the lazy programmer rule. So I'll go ahead and submit the first line of code by highlighting and pressing F3. And sure enough, I am going to get a note in the log saying path not resolved. So I do need to make sure that I also highlight the %let path statement and execute. Now that should work. I'll blow the screen up a little bit so you can see a bigger font size. And we have those magical words we are looking for. Successfully assigned, use the XLSX engine. I'll do the same thing for the ORD live name statement. Highlight, execute, check the log. And that's also successfully assigned. A quick note here, I have set up my studio session so I see the code and log. All logs associated with a certain piece of code or output all come together in a tab format. If you wish to split it out and have a separate code and a separate log, you can certainly do that, and let me show you how. I'll head over to the three dots, the ellipsis, and I'll go to more options, and there I have a tab layout right towards the bottom of the selections. You'll notice I selected single, but I'm going to change it to vertical split to show you what I mean. You see that? Now I have a separate code tab and a separate log tab. Personally, that takes up too much room on my screen. I'd rather have my options set up the way I had it on a single tab layout. All right, so we've got the two live name statements executed. Can we go check the library icon? And can we go and check the two libraries, CST? If I expand that, what do I see? Lo and behold, I see a library called CST, and within that, a dataset called customers. If I expand further, I will see all of the column names as well as the types. The customer ID is numeric, everything else is character. Pretty nifty, and I'll do the same for the ORD library. I see that it has a dataset called orders, and within that, I see all of the column names within the orders dataset. Now, do bear in mind that I am alluding to these as a SAS dataset. I'm alluding to this as a SAS data library. We have to remember that this is really an Excel worksheet masquerading as a SAS dataset. CST is an Excel workbook masquerading as a SAS data library. It just so happens that the live name statement made my life so easy. And that's how easy it is. A single live name statement pointing to the Excel workbook, specifying the engine, specifying the libref, and you're done. You brought in Excel so that we can start to work with SAS using ProcSQL. Now that I brought in the Excel workbook and worksheets so that they are like SAS data sets, I can actually start to do some work using SAS code. And before I dive in, I have to remind you, if you have already done this before, you know what I'm talking about. The number one rule for all data workers, you know that rule, know thy data. Know thy data has to be the number one principle for data workers. Whether you call yourself a data analyst, whether you call yourself a data scientist, um, regardless of your job title, if data is central to the work you do, then there is no magic pill that will forgive you for not knowing your data. And that's what we're going to do in this second segment of my presentation. We're going to learn to get to know the data of these two data sets. So I'll open up my code snippet, and here I have an amazing concept. We're going to dive into ProcSQL, and we're going to look at a concept called dictionary tables. Dictionary tables contain a wealth of metadata, which means really data about your data. So there are about 30 dictionary tables, but we'll be focused at only two of them for this presentation. One of them is called dictionary.tables, and the other one is called dictionary.columns. The way I look up these dictionary tables is very similar to all other code I would write in ProcSQL. But before I even start to look at the data, I want to look at the metadata that's contained in these dictionary tables. So I use a describe table statement, and I'll execute that on these two dictionary tables using ProcSQL. Then in the log, I'm going to see a note, and SAS tells me the SQL dictionary table was created like this. It has the name of the column, the type of the column, the length of the column, the label of the column. Super handy, especially when I look at things like MO date or CR date. I have no idea what that stands for. But if I head over and look at the label, it makes sense. That's date created and that's date modified. And then if I look further at the second dictionary table, which is the columns dictionary table. And these dictionary tables, by the way, are meta tables, which mean they store information about all your data sets and all your libraries that you have pointed to. So now the second dictionary table is dictionary.columns. Again, I have a describe table statement executed, and SQL executed the code and tells me these are the column names in your columns dictionary table. And that's good. And if you really had that curiosity to dive deeper, you could always head back into the libraries icon, expand SAS help, and all the way to the very bottom, you'll see these views which are preceded by the letter V. So if I look at V column and I expand that, I'm going to see the names of the columns. But if I double click and open it up, I'm going to see a lot of information. For each column is going to appear in this dictionary table, right? That's the name of the column, and all of these columns from column 1 to column 10 that is visible on my screen belong to the customer's data set, which is really Excel masquerading as a SAS data set. As I scroll down and go further down, I'll notice that SAS goes on opening more and more libraries. So this is not a very efficient way of interacting with dictionary tables, but I wanted to show you quickly in case you were curious. So we can go back to code, which is likely the best possible way to interact with dictionary tables. It's efficient and we can subset the data using these dictionary tables. One more thing I want to do to get to know the data is actually look at the data itself. So I want to look at the data for these two dictionary tables. Rather the metadata, I looked at the master metadata for all dictionary tables, for the columns and the tables dictionary table. Now I want to look at the information for these specific tables, almost as a proc contents, if you will. And so comes back in the log and gives me that important, informative knowledge about my data, the customer's data set, right? Here's the column name, here's the type, here's the format, here's the label. And as I scroll through, I see that there's information about the second table as well. And that's pretty informative. Um, there are resources that we will have for you if you wish to explore this further. But we want to get to the business on hand, which is starting to analyze these Excel workbooks. And that's our topic in the next piece of code. And up until now, we have pointed to Excel in segment 1. In section 2, I've shown you how to get to know the data. Now let's dive in and open up section 3, which is going to be the topic of joins. Let's make our screen a little bit wider in terms of code. So we are going to join the customers table with the orders table. In the language of SQL, we have a lot of lines of code. And I'm just going to punch in the order of syntax. So if you type a proc SQL statement, the first is the select, the biggest line is the select, and then the from, and then the where, and then the group by, and then the having, and then last but not least, the order by. So this is what makes up your proc SQL syntax block. And if you don't remember the syntax or the order, a handy mnemonic is so few workers go home on time. So true, isn't it? With the switch to a lot of workers working remotely and the possibility of working remotely, that is certainly true. So these are all of the building blocks that SQL needs. The select says, give me or list for me all the columns you wish in the final report. The from is asking for the tables where you want to pull the data from. The where acts as a filter. The group by does grouping. And if you notice at the syntax is so close to the English language, this is certainly true of SQL. The having cuts through the group data. Difference between the where and the having? The where acts on individual rows of data, rows that have not been summarized, and the having acts on filtering the grouped data. And lastly, there's the order by. You are not compelled to write all of these building blocks when you craft a SQL query. Two things that are mandatory is the select and the from. Everything else is optional. So let's go and dive into our code where we are going to join tables. So I've got my select invoked. I actually have invoke proc SQL first line, bring SQL into memory, and then the select where I list the column names, the from where I list the table names. So on the from, I list the first table that I need. It's the customers table. And then I also list the orders table, specifying the library and then the table name. Well, notice that I have given an alias for this customers table as well as an alias for the orders table. This is really important. SQL says when you're joining a table, you need to specify a join condition. So that goes on the on clause. When you're joining a table, also please tell me whether you want matching rows, which is an inner join, or matches and non-matches, which is an outer join. We want matching rows, so we specify an inner join. So you've got the two tables listed on the from. Combine that with an inner join syntax, and the on clause we specify the join condition. So let's go back to that comment about the alias. That alias becomes super duper important here because we are asking for matching rows on customer ID. Now, SQL has no problem that the same column name is in both the tables, but it does say, please tell me which customer ID this is, meaning which table it's coming from. And that's why we provided an alias so that it became very clear on the on clause, this is the customer ID from the customers table. And the second one, o.customer ID, refers to the customer ID on the orders table. And that's it. On the select, then I can go and specify all the column names I wish. Here is another way of qualifying your column names. I have preceded the column name with the letter C, indicative of the fact that this customer name is coming from the customers table. The only time SQL really needs this is if you have this column name appear in multiple tables. Quantity does not appear in multiple tables, not as retail price, so I have not qualified them. I'll submit this code and let's take a look and see what happens. The joining is happening and voila! What we've done here is joined two Excel worksheets together in SAS without ever leaving the comfort of your studio environment in SAS Viya. So I've got here information about customers and orders. That was the whole purpose. I wanted to join these two tables to get every possible bit of information about my customer. And I can scroll down and see how many rows there are. But SQL is not very chatty. In the log, it just says so many observations, but it doesn't say how many observations in the output report. So I have a handy macro here called SQL OBS. Ampere equals SQL OBS is a special variation of this macro. Let me execute this. With a percent put statement, I'm going to see the value of that macro variable. And the ampere equals SQL OBS allows me to see that macro variable in this format, name of the variable, and then the value. So I got 364 rows that were returned from this first join. Now, if I want to go and try to combine the two tables with an alternate syntax, On the from clause, I list the first table, separate that from the second table. What this will do and why I have a subset here is a very important question. Why do I have a subset of data? And why have I chosen to show you a from clause in an alternative syntax? This is a key point because this could crash your system. When I have multiple tables listed on the from clause and I don't specify a join condition, SQL is going to return me a monster. This is called the Cartesian product. A Cartesian product is all possible combinations. Since I have a lot of rows of data, I want to just work with the segment, a subset. So I've turned on an option called ANOBS equals 50. Exact same select. The only difference is I use a slightly different form of the from. Now what's going to happen? How many rows of data will I get? Let's go ahead and execute all of this code and let's take a look at the results. Now I'll scroll down once again. I don't see the row numbering. I go to the log, and of course, there are warnings about only 50 records were read. But take a look at SQL OBS. This time, I have 2,500 rows. Remember what I said? A Cartesian product is built when I have multiple tables listed on the from and no join condition. So this can really mess up your system and freeze it. So it's important to know not to try to build your joins in this fashion. Chances are you might forget it. The on clause is the way to go about providing the join condition. It's optimal because the on clause is actually related to the from. So a bit of an efficiency there. All right, let's join entire tables. Let's go back and let's do the complete join. Let's pull out the inobs option. Let's execute this code and we're going to see the exact same result we saw before. I don't no longer need to see the results. I'll go to the log and I'll see that number 364 matching rows only. However, if I was to look at the results, I'll notice that there are things like quantity and retail price and order date, but the data is not really ordered in a manner that's intelligent, and I want to throw in an order by. So ordering the data is as simple as sticking in the order by. So here I'd like to order the data and I'd like to order it by customer name. Handy tip here, it might be a little cumbersome for me to type out the column name, and SQL says, I've got your back. You don't need to type customer name. Just give me the integer position of the column on the select by which you want to order the data. So happens I want to order by customer name, so I give an order by 1. If I had multiple columns that I wish to order by, I'll just separate them with a comma and then add the second column name. That was an example to show you. So this time, if I execute this query, not only have I joined the two Excel worksheets, in addition, I've also managed to sort the data in ascending order by customer name. Done and done. So that was the simple conditions for the join. You could make this as crazy complex as you wish. For now, we are satisfied. We've completed an inner join. We've understood the challenges of crafting a join where we miss the join condition and we end up building a humongous report with all possible combinations called the Cartesian product. So far so good. We've joined our tables. We know how to get a subset of data. Let's move on and let's try to summarize these Excel worksheets. So to summarize the data, and move back up and let's look at the code again. The select gave me my column names that I want to see in my report. The from gives me the table names from which I want to select the data. The where allows me to filter the data. The group by allows me to process the data in groups, and this is the statement we'll be learning to use. So let's move on to the next code snippet. The next section is to summarize data. Plain and simple, I want to take the orders table and I'm curious if I go and look at the orders library. Let's scroll all the way to the top, minimize my SAS help library. If I open up this orders dataset, which is really an Excel worksheet, I do love saying that, I'll see the information contained in this dataset is things like numeric columns like cost, discount, quantity. I'm super interested in how much quantity each customer ended up purchasing. So I'm going to group the data and try to get a sum of quantity. I'm going to group the data by customer ID, and that's as easy as it gets. What I'm thinking in my mind in the English language is how I craft my query. Now, certainly, I know how to group the data. I've added the group by, and then I also need to give SAS one more key piece of information. Telling SAS to group for each customer to get the sum of quantity is going to come on the select. So how do I tell SAS this information? On the select, I have customer ID certainly, and then I have sum of quantity, and that's where I provide my summarization. Looking at this, SAS will say, oh, you got the group by. So I'm going to roll up every customer. If they have multiple times that they purchase, I'm going to roll them up into a single row and I'm going to add up all the quantity they purchased and stick that in one row for each customer. Couple of things to bear in mind with the group by. You want to be able to use a group by on columns like customer ID, not on your summary column. You want to use it on your non-summary column. So let's do the simple summarization and let's see how many rows we get. And so it gives me a running listing for each customer. What is the sum of quantity? And if I look at my log, I should see I have 3,682 customers, unique customers in my orders table. Let's head back to the code. While that report gave me the sum of quantity for each customer, it was not really informative. What I'd like to see is a more intelligent report, meaning, how about SQL give me each customer, but I want to see the sum of quantity in descending order. So I want to see the customer that purchased the most quantity on the top, and then a little lesser and a little lesser, and so on and so forth. So how do we achieve that? You already saw how to put in the order by. So all I need to add in this piece of code is the order by. Order by 2. 2 is the second column. Order by sum of quantity, and I threw in the descending keyword. So let's go ahead and execute this code. And we should see a more informative report emerge. Now I'm going to see which are those customers that had the most quantity that they purchased. And then at the very bottom, I'm going to see customers who had the least possible quantity. Now I don't know how many rows of data there are, so I'm going to invoke that macro and have the value put out in the log and 3,682 rows of data. Suddenly I decide this is all fine, but I want to limit my search. I'm thinking of targeting my Swiss customers just because the idea of the Alps is so fascinating. So I'm going to throw in a where clause. And if you recall, the where goes after the from. In order of syntax, it's to select the from, the where. On the where, I'm going to ask for country and I'll examine the orders dataset. In there, I've got a country column. So I'll say where country equals. Now I'm stumped. I don't know what the values are. And if I double click to open up the data set, it's really large. It's going to be a waste of resources. So something that is really handy is a proc SQL query where I can ask for distinct values of country. And what that does, and I'm going to say, please go to the ord.orders dataset and provide me this information. And so what SAS does is something quite interesting. SQL goes in through the data and it makes two passes of the data when it sees a select distinct. The first time it goes through, it orders the data, and the second time it blows away duplicates. So I'm not going to see duplicates, I'm just going to see unique values of country. There is Switzerland, there is the spelling of Switzerland. I'm going to copy that over. And the whole purpose of select distinct was to get an idea of the way Switzerland is spelled. On the where clause, another thing I need to bear in mind is a principle that needs to be respected. And that goes like this. Like has to match like. If country is character, any comparison to the right must be character. So enclose in quotations. And SAS doesn't care single or double quotes. So where country equals Switzerland, now I'm going to go through the data. I'm going to run this query again, and I'm going to get sum of quantity just for my Swiss customers. So let's execute this code and let's see what we get this time. Far fewer rows of data as expected, and I can see that there's about 3. If I check my log, it'll also tell me, assuming I ran the percent put SQL OBS, there it is, 8 customers. 8 customers in Switzerland, and I'm able to see the quantity that they purchased. It rolled up into a single row, so each customer appears on a single row of data. Now that's all very fine. Am I limited to only using GroupBy by specifying a single table? Didn't it just show us how to join tables together? Certainly, you're not limited to a single table. You can stick multiple tables, especially if you have data that you need from multiple tables. You can put them all on the from, and then you can do grouping and summarizing. So let's see how to do that. Here I'm going to join 2 tables, and I'm going to summarize to get the sum of quantity for each customer. So once again, starting from the select, column names I wish, 3 non-summarized columns, 1 summarized column. And then I've got a grouping by customer name, city, and country. For this combination, I want to see the sum of quantity. On the from clause, I list the first table, and then the inner join the second table. On the on clause, I specify the join condition. And now let's go ahead and submit this code. And I'm also going to include in this selection the SQL OBS. I'd like to see the number of rows. Actually, let's toss in an option called number on the proc SQL statement. So right away, I'll see how many rows I have. Now I've done multiple things. I've joined tables together, and I've also summarized them and grouped them. So this time, I'm going to see these customers appear, 280 customers. Not terribly intelligent looking data, so I need to do a few more manipulations in the code. So not only do I want to present the data better, but I'm also curious, am I limited to summarizing by only one column? Can I not have summary statistics for multiple columns? And the answer is a resounding yes on both counts. I'm going to go ahead and summarize two columns now. So earlier I did a sum of quantity. Now I'm going to sum quantity as one column and sum of retail price. So those are my two summary columns. Once again, on the select, I'll stick the columns I wish, the non-summary columns, the two summarized columns. On the from, I'll list the table. I'll specify the inner join syntax, the second table. On clause, specify the join condition and the group by, specifying that I want the data to be grouped by these three columns. And there is the order by. I want to order by country. So let's take a peek here, and I'll include the OBS macro, execute, and voila, here we have those two statistics appear. They don't have any description, so we're going to stick labels on those. And I see that the data is now sorted by country. Great, I've seen how I can build multiple summary columns. However, I noticed a gap in the results. There were no descriptive labels for these columns. Also, ordering just by country doesn't serve my purpose. I'd like to see the data ordered by two columns, by country and by retail price in descending order. So I'll proceed to do just that. So here's how we do it. We'll add a label to the column names. Sum of quantity has a label. Sum of retail price also has a label attached to it. It's so easy to add a label just beside the column name in quotations. Add the label. This is ANSI SQL. If you wanted to go SASism, you would type in right after the name of the column, you would type in label equals. When is ANSI useful? ANSI is super useful if I am going to be moving my code to an Oracle environment and expecting it to run there. And a SASism is handy if I never plan to leave SAS and I stay right here. I'll leave it as ANSI and then added the labels. The rest of the code is identical. On the order by, I have the column name, country, and then I've added the fifth column, which happens to be sum of retail price, and I want to see that in descending order. Let's see what changes happen when I add in these modifications. Let's see how the report changes. That's completed. First action, I see that I have those labels appear. Labels are really handy because they allow me to add special characters like blanks in between or any other special characters. And then I can see that the data is ordered by country and within that by retail price in descending order. So to recap, so far we've learned how to summarize data, we've learned to summarize by multiple columns, we've learned to group the data and order it as well. And we've thrown in an inner join so that we can join tables and do all of this work all together. Now we're getting to start to get a little curious about what else we can do. If I can calculate the sum of retail price for each customer, can I also find out how many customers spend more than the average of all customers? So the question goes like this. How many customers spend more than the average for all customers? So to do that, we're still going to use this as a starting point, or we're going to have to learn to use another clause. So let's scroll down and let's first find out what is the average. What is the average of retail price? And that's with the function called mean. And that's just going to give me one number. It's going to go through the entire data and bring back the mean of retail price. And that is this number here. I'm going to copy this and I'll tell you in a second why I need to copy it, but I'll just copy it for now. Now I need to go and build what is called a subquery. A subquery is a query that sits inside of a query. So it can sit inside a where or a having clause. So this value I can embed against a where or a having clause. If you recall, the having is what's going to cut through or filter group data. So I've got the exact same code here. I'm going to just push this line of code right below so it's clear. So I've got the same select, the same from, the same group by. Now I'm saying I only want those customers because remember we had rolled up every single customer's information into a single row. And so I've summarized customer data. Now I want to see which of those customers has a retail price greater than that average that I just calculated. This is the average for the entire table. This is the retail price for a rolled up individual customers. The having clause allows me to cut through this grouping of data, to subset this grouping of data. So here I've embedded that hard-coded value, and then the order by remains the same. I want to order by country and by sum of retail price. So I'm going to execute this code and examine the report. So now I have, these are the customers whose sum of retail price is greater than the average for all customers. And in the log, I see we have 91 customers, as well as a note that says the query requires remerging summary statistics back with the original data. This is going to happen anytime I have individual rows of data and I have summarized data appearing on the select. And that's basically SQL reminding me this is what it did. Now, when I do this work, I noticed that there was a lot of manual labor. I first had to run this query that calculated the average for the whole table. And then I had to go to the output window, the results window, I had to copy it, and then I had to come back and paste it. What if the customer data keeps on changing and the orders data goes on changing? That means I have to resort to manual labor. I have to go back and calculate the mean, run it again from the orders table, and copy paste it here. So anytime there's manual intervention, I hesitate. There's a possibility of human error that creeps in. So I'm going to have to move away from manual intervention and write a subquery. As I mentioned before, a subquery is a query within a query. So all I'm going to do is where I had hard coded the mean, I'll just stick in that entire first query in there. That's all it is. This here is an example of best practices. It's called a non-correlated subquery. Non-correlated subquery are self-reliant, just like you are, independent. They are able to perform their work, and the work happens inside out. The inner query is resolved and then it passes values to the outer query. This is really best practice. This is what we should be aiming for. And so how do I know that I followed best practices? Well, what I would do if I'm just starting out with subqueries is construct that inner query first, let it run so I know that this query runs independently. It had no problem executing. And then I can copy and paste that query onto the having clause. Let's see if this works. We've talked about this and now let's examine what the results would be. And voila, we get the same results. In the log, I should see the same number of rows of data, 91 rows of data. That is what is called amazing automating of your work. And so we were able to summarize, if you recall, these two, what look like SAS datasets, are actually Excel worksheets. We've managed to join two Excel worksheets and we've done some crazy complex work here. We've summarized the data, we've gone and grouped the data, we've gone and added in a subquery, and we've ordered the data. Next, we're going to see some more interesting things, and that is, how do I write this information back to Excel? And we'll head back to our last code snippet, write data back to Excel. So here we have a create table statement now that's showing up. The create table statement allows me to take whatever query I've constructed and send the results this time to a table. I have really three options of sending results. First is to the results window. That's all we've done so far. The second is to create a table. That's what we're doing here. The third option was to create a view. We're going to create a table. And let's do that. Only change in code is the create table statement. I still have my select with the standard column names as they are, the three summarized column names with labels. On the from clause, I've listed the first table, inner join syntax, the second table, on clause specify the join condition, group the data, and then on the having clause, thrown in a subquery and order the data. Phew, that sounds like a lot of work, but not the way we've explained it and not the way SQL will transform the data. So I'll execute once again, and this time I know I'm not going to see the results window pop up. I am going to see that SQL has built a table called cst.summary. And I'm going to go and see what this cst.summary table looks like. There it is. I'll double click to open it up. And I'm going to see the standard country, city, customer name columns. And then yikes, the last three columns, the summary column, SQL said to us, you did not bother giving me a column name. Labels are not enough. So I'm going to give these names such as underscore tem A001, underscore tem A002, and underscore tem A003. Yikes, yikes, and double yikes. So we're going to go and do something to rectify that situation. We are going to add in aliases for each column. So sum of quantity as sum QTY. We won't rely just on the label. That did nothing for us. We'll do the same for the remaining two summary columns. And we'll give that a spin. And this time, when I open up this cst.summary, I should see a slightly different looking data set with more intelligent looking column names. All right, so that was how you would write back. But wait a minute, didn't you just say you're going to write back data? Indeed. If you remember, CST is nothing other than an Excel workbook. Within that, you have two sheets called customer and summary. Don't take my word for it. Let's do one last step. Let's unassign the CST library with the clear and the CST library vanished. Now let's head back to my Explorer window. Let's open up the customers. Let's download the customers file. And let's open it up. And voila! Sitting in the comfort of SAS, you are able to write back your summary information to a brand new sheet in the exact same Excel workbook. Truly magical. This ability of SAS to be able to connect to Excel just by pointing to it, just by pointing simply by using the live name statement and then doing all of this work. This is how we want you to do the work, to do all of the analytic work in SAS. Excel is not an analytic spreadsheet. It's mostly for storing data and doing some work there. But with the help of SAS, I'm able to do all of this work and then furthermore, not just read Excel, but write back to Excel. That's how easy it is to bring Excel into SAS Viya. Punch in some ProcSQL code and away you go. Did you enjoy the session? Feel free to ask any questions. What helped you the most? Until next time, thanks for watching.